There we go. Great. So for me, it's a real honor to be here on Women Who Code. It's an initiative I've been following for quite some time, and finally I get to be speaking. Just a quick hi to Jessica, who's in the chat. She's one of my colleagues from Ocero, all the way from Brazil. I'm actually in Spain. She's in Brazil. But let's dive into this talk. So today we're going to be talking about securing your applications. Now, I know as developers, we have a lot to take into consideration. So hopefully this talk is going to give you a general overview of what sort of attacks can happen to your applications. And also what we're going to see are a few solutions for you to implement into those applications. But before we do so, I just want to talk to you a little bit about why we should even think about security. Sometimes it's obvious, but I just wanted to share some numbers with you that I found were quite quite bad, right? So first of all, we have the 39 seconds. I've been speaking for more than 39 seconds now, so a hyper attack has actually happened. And one of these happened every 39 seconds. Now the problem is that it takes around, on average, 196 days to find a data breach after an attack has happened. Now imagine how much harm that can hurt a company, how much harm it can come to our applications, and so forth. And last but not least, last year, 75% of organizations they experienced some kind of phishing attack. Now, I don't know about you, but I know if I go into my spam mail right now, I'm going to have a bunch of phishing attacks. So that's a good thing that a lot of email providers do prevent these, but they're still the main source of attacks. And we'll see this in the talk today. Now, we're here to help, and who are we, and why am I saying we and not I? Well, this is my colleague Sam Bellin, and me and Sam created this talk together because we both have a bit of knowledge and security when we put our minds together to build out this talk. So hopefully you'll find it useful, but it will just be me talking today. But feel free to reach out to either Sam or myself about anything I talk about in this talk, or about authentication, identity, security. These are our Twitter handles, and we'll be more than happy to help. I'm a senior developer advocate engineer at Ocero, so is my colleague Sam, and so is my other colleague Jessica, who's in the chat. And that's what we do. This is what I do. I come to give talks. I am here for the community. I love to give back to the community, and that's why I love being a developer advocate. But enough about me. Let's get into the talk and figure out what this talk is actually about. So we're going to start looking at client-side attacks. And this is basically what the talk's going to be on today. There are server-side attacks, but we're going to focus on just client-side attacks again. And to make it even smaller, I've broken it up into the 4 most common attacks for you. So we have the XSS attacks, also known as cross-site scripting attacks. We have CSRF attacks, which are cross-site request forgery attacks, clickjacking, and third-party assets. And in each of these attacks, I'm going to show you a scenario of what that might look like so you get a better understanding of how all this works. Starting with XSS. So an XSS attack allows an attacker to inject a script into the content of a website or application. When a user then visits the infected page, the script will execute into the victim's browser. This will then allow attackers to steal private information, like cookies, account information, or to perform custom operations while impersonating the victim's identity. So we could go even further into this attack. And this attack, inside of this cross-site scripting attack, we have 3 different attacks. We have reflected SSS, stored XSS, and DOM-based XSS. So let's take a look at the first one, which is the reflected cross-site scripting attack. Now, this attack is also known as non-persistent, and it's when a temporary response from the server could be tricked. These tend to occur when the attack is reflected off a web server via a search result, error message, or any response which echoes the user-provided data back to the user. Reflected attacks are normally delivered via a link. So you can imagine that this would be through some sort of phishing attack where they're trying to get you to click on a link. Now let's take a look at this scenario. Now we have a baddie, and this baddie is going to find a vulnerable website. And in this case, it's going to be a search engine. The problem with this search engine is that the search function receives the user-supplied search term in a URL parameter. And then the application, what it does is echoes that supplied search term in the response to this URL. Now, assuming the application doesn't perform any other processing of the data, an attacker, well, they could construct an attack like this. And what's the URL going to do? Well, it's going to do the same thing, and it's going to inject that JavaScript. Now, the baddie, what it's going to do with that link, it's going to grab it and it's going to send it to the user. And that normally through a phishing attack, like this is a phishing email I found. Obviously, it's very obvious phishing email, and it was in my spam. But just so you know, not all spam filters cut out phishing emails. And also, you need to be really careful because some of them are really, really good. But here it's a bit more obvious. But say I were to click on any one of those links, it might take me to, it's going to send a request, right? It's going to send a request to the web server. And as it's a vulnerable site, it's going to reflect that code back to the user. Now, just note that no website should take arbitrary input from the user and then reflect it back to them, especially JavaScript code. When the user opens the web page, the browser is going to start parsing the website, and then it's going to execute the JavaScript code that was sent by the baddie. Consequently, that data is then sent back to the baddie and through the code that the baddie injected into the URL. Now, in this scenario, in this case, in reflected SSS, the attack only affects the users that click on that URL. But let's take a look at a different attack so you understand how it can affect different users. We're going to now look at stored XSS, and it's also known as a persistent attack because it's when we add something to a database. It's data that lives a very long time. Now, what you can think about is, for example, you comment on an image on a social media platform. That data is stored forever. Like, you can go back to that image years later and it's probably still there and the comments are there. But what happens when the other people see that comment? Well, their browser downloads and displays that from the web server. And it could be the same process as reflected SSS in adding JS code into an input field, but this time it's a comment. And unlike reflected SSS, this would then affect all subsequent users that visits that particular page. So anyone who goes to look at this image and looks at the comments, those would be the victims. Because basically once the user visits that page, the server is going to show all the comments that are there, including the one from the baddie, which was JS code. Then our browser does what it does. It's going to execute that code, and some data will then be sent from our victim to our baddie, maybe through cookies. So again, our baddie is going to discover a vulnerable website. And please note that I am saying a vulnerable website. If you go to Facebook, it's not going to happen to you because their website has a lot of security measures in. And that's where they can, but it has to be a vulnerable website so they can actually inject the malicious code. So our baddie is sending some data to the web server that's then being injected into the server. And the server has stored this data, and so every subsequent user that visits this particular page on this particular web server, their browser is going to download and execute the code, which includes the comment that the baddie did. Then due to this code, the user's data is sent to the baddie, and then the baddie can do whatever they like with this data. So what's the most important thing here to remember is that our victim's browser is being coerced into sending the user's data to the baddie. Last but not least, I'm going to talk about this last attack, and then we'll take a look at some solutions. But we're going to talk about DOM-based XSS. So this attack happened, well, on the DOM. And a good example of this is an auto search function. So it's basically every time you type, the page you're viewing gets updated. You don't need to refresh or go to another page or anything. And this is where DOM-based XSS differs from the above. The server is not required for this. It's all taking place on the DOM. And what's the attacker doing? It's abusing the runtime embedding of user-supplied data in the page. Now, JavaScript takes data from an attack controllable source, for example, a URL, and passes it to a sink that supports dynamic code execution could be eval or inner HTML. And this enables attackers to execute malicious JavaScript, which typically allows them to hijack other users' accounts. So let's look at what this scenario might look like. Again, we have our baddie, and it's going to find a vulnerable website, maybe this time with a language setting. For example, Spanish, as I'm in Spain. And the baddie can inject its malicious code into the URL again. When the victim clicks on this link, the browser sends a request for this page.html to Evil Corp in this case, and the vulnerable website receives a request and provides the page, but the server doesn't process the malicious code. It's the client-side JavaScript that accesses the malicious code and runs it on the user's browser. The original JavaScript code in the page does not expect this. It does not expect the default parameter to contain HTML markup, and as such, it simply decodes and echoes it into the page, or the DOM, at runtime, and then the browser then renders the resulting page and executes the attacker's script. Now, please note that the HTTP response sent from the server doesn't contain the attacker's payload. I have to emphasize on this. And this payload manifests itself at the client-side script at runtime. When a flawed script accesses the DOM variable, document.location, and assumes it's not malicious. So just so you know, most browsers URL encode document.location by default, which basically reduces the impact or possibility of many DOM XSS attacks. So browsers are much better at this now, so keep that in mind. So where can XSS attacks happen? They can happen in user-generated rich text, anywhere where you can drop an iframe, anywhere where you have control over a URL, where input is reflected back, query params into a DOM, or .innerHTML or eval. Now, for those of you who don't know, .innerHTML is a JavaScript tag, and its property is used exactly for DOM manipulation. More specifically, what it does is it sets or returns the HTML content of an element. And basically, because of the way that .innerHTML can add text and elements to a web page, it can easily be manipulated to display potentially undesired or harmful elements within other HTML element tags. So please keep that in mind. Try not to use .innerHTML. What solutions do we have? Because I just threw a whole bunch of attacks at you, a whole bunch of problems. So what solutions are there? Most importantly, what we should never do is accept actual JavaScript code from an untrusted source and then run it. For example, a parameter named callback that contains a JavaScript code snippet. Basically, no amount of encoding or escaping can fix that. But in the case that you do insert untrusted data into HTML, JavaScript, your attributes, CSS, or URLs, make sure you encode them. Now, the good thing is that most web frameworks, and I know Angular well, and Angular does this really well, as long as you stick to the rules and not try to do any little tricks or hacking. Most frameworks basically have a method for this, for the HTML encoding, escaping, and what we should be doing is encoding and escaping the following characters, basically to prevent switching into any execution context such as script, style, or event handlers. Another solution is if your application handles markup, it can be very, very difficult to validate. Encoding is also very difficult on HTML markup since it will break all the tags that are supposed to be in the input. Therefore, there are specific libraries that exist, and what they do is they parse and clean HTML formatted text. And last but not least, user input should be treated as values, not code. So keep that in mind. Let's go on to our second attack. Just before we do, I'm going to drink a bit of water, but I'm going to put up the next slide so you can read it while I do that. Okay. So CSRF takes advantage of the fact that the browser will save cookies or basic authentication credentials. Then the browser will also attach those credentials all those cookies to any request to the same origin that's been made after the browser has saved those credentials. So, for example, in the case of basic authentication, when you use a basic authentication header and the browser shows you a username and password login form, it's basically what this is it's a native login form from the browser. And anything you enter in this form will be saved by the browser, and then those credentials will be attached to any request after this when the request asks for basic authentication. And the same thing goes for cookies. Once the browser has saved a cookie, it will attach those cookies to any request after it has saved the cookies. So let's take a look at what this scenario might look like. We have a user, and a user is going to log into the online banking app. Then the online banking app is going to verify the username and password, and if that username and password is correct, it's going to issue an authentication cookie, which will be saved by the browser. Now, for each of the following requests the user is going to do, the browser is going to attach that cookie so that the user doesn't have to log in with each request after they have already logged in. Otherwise, that would be very annoying. And the problem here is we can actually abuse that behavior, that the browser is attaching that cookie. For example, we could set up another phishing site through a phishing email, and this phishing site might look exactly like your banking app, so that the user doesn't even notice they're on a phishing website. And trust me, this is a thing. They literally imitate websites. And then you go to this phishing site, and this phishing site is going to do a fake request to the real banking app. And instead of maybe transferring money to a friend of the user, they can transfer all of the money to the malicious third-party baddies. So by forging a request, we'll be using the behavior that the browser will attach the cookie automatically on the request to the banking app because the user has logged in previously, which means we can steal all of the money. And to demonstrate this, there's a small demo here. And here we have a demo where we set up a phishing site. And this site welcomes you to EvilCorp, which will show you a link to the real banking app's login website. And once you log in, you can continue. We'll see there is money in both accounts. And once you revisit the evil website, the website will now know that I'm logged in because I have that cookie attached to it. So it will do a fake request to the real banking application with that cookie attached, and it will steal all of our money. So as you can see, both Sam and myself have €0, which is great. Okay, let's see, there we go. So what solutions do we have for a CSRF attack? One possible solution can be to use a CSRF token. Now, a CSRF token is a unique, non-guessable token that will be issued with the first request. So this will be issued when you also issued that token. And every request that we use, that token will also have to send that CSRF token to be able to use that cookie. So, for example, if we were to do a request without the CSRF token, your bank account would know that you're attaching a cookie, but it's not sure if you're allowed to use this cookie because you haven't sent it that CSRF token, which means that only the original user of that token can use that cookie to do authenticated requests, and every man in the middle or third party or baddie that tries to forge a request without that token, they won't be able to do so. Another solution might be to use a token-based approach to do authenticated API requests. Now, OAuth and OpenID Connect, where you issue an access token and you use the access token as a bearer token with each request, because access tokens or bearer tokens are not automatically attached to API requests, so the browser will not automatically attach those forged requests. Also, forgery requests in modern browsers are a bit more difficult than they used to be. For example, modern browsers do not attach cookies to cross-origin fetch requests by default, which means that if you use a fetch API in JavaScript, you have to specifically tell the browser to fetch the cookies if it's a cross-origin fetch request. And you can do this by setting the credentials to include. By default, it's same origin, which means it will still automatically attach those cookies. And if it does an API request to the same origin, if it's cross origin, you have to specifically say this. But if you do a HTTP form post by using the HTTP form element with an action and a method, the browser will still automatically attach that cookie even through cross-origin resources. Also, modern browsers do not attach cookies when the access control allow origin is an asterisk, which basically means that it will allow all origins. You have to specifically set a list with one or multiple origins that are allowed, and then the browser will attach the cookie. But if you leave it with the asterisk to catch all, the browser will not attach that cookie anyway. We have two left, so clickjacking. Clickjacking is known as a UI redress attack, and this is, I shouldn't say favorite, one of my favorites because that's just so wrong, but it's basically when is an attack that tricks a user into clicking a web page element, which is normally disguised or invisible as another element. So this is the kind of stuff we think about, right, when we think about those baddies. So clickjacking can cause users to unwittingly download malware, visit malicious pages, provide credentials or sensitive information, transfer money, or purchase products online. The attacker creates a page telling the user that they have a fine they need to pay straight away. So the baddie's creating this page and say, hey, you've got a fine that you have to pay straight away. So here what the attacker is also doing is playing with emotions, and they like to do that because you think, oh, I have to do this right now. Then the baddie, what they're going to do is they're going to grab that URL and send it to the user. The user then clicks on the URL and is going to send a request to the web server and makes the transfer. When they click on the button submit, they're being clickjacked. And this can cause several things to happen. It can cause users to unwittingly download malware or redirect them to a malicious web page. It might provide credentials or sensitive information. It might even transfer that money to the baddie or purchase products online. Typically, clickjacking is performed by displaying an invisible page or HTML element. And we're going to see this now here. So it typically happens inside of an iframe on top of the page the user sees. For the sake of this demo, it's not the case. It was just to show you how easy it is to hide an element. Now the user believes they are clicking the visible page, but in fact they are clicking an invisible element in the additional page transposed on top of it. Like you can see in the button now. Right. And what solutions do we have for clickjacking? So here's where we should focus on the X-frame options. So the X-frame options response header is passed as part of the HTTP response of a web page, indicating whether or not a browser should be allowed to render a page inside a frame or an iframe tag. If you set it to deny, the page cannot be displayed in an iframe, regardless of the site attempting to do so. And please note that not only will attempts to load the page in a frame fail when loaded from other sites, they will also fail when loaded from the same site. On the other hand, if you specify same origin, you can still use the page in a frame as long as the site including it in a frame is the same as the one serving the page. And to do this, this is an example with Helmet, well, was expressed with Helmet. And as you can see, we're having the app.use here, and we have Helmet, frame guard, and action same origin. Last but not least, we have third-party assets. Now, another thing third parties try to misuse is, or baddies try to misuse, is the use of third-party assets. Now, I'm really curious, and feel free to put this in the chat. How many of you check every single external library you use? How many of you check your NPM packages if you're JavaScript developers? How many of you check it? I'm saying nope, never, nope, nope, never. Okay. So whether it's something you store through NPM, Maven, Composer, or any of the other package managers out there, we tend to just download the package and import it into our code base because, well, we don't really give it much thought and assume they do only what they say they do, right? Sometimes we don't even really read what they say they do. However, there might be some malicious code in there that tries to steal credentials or cookies or local storage. So should you really be trusting them? Well, for the most well-known ones, you can usually trust them as they have security measures in place, but be aware that sometimes baddies try to misuse package managers to get access to your code base. And here's a few examples. So I, for one, I'm really bad at typing. I do a lot of typos. And for me, it can be tricky sometimes to write the name correctly, even if it's a package that I know, like the auth0spy.js. And baddies take advantage of that. So before you install a package, be sure to go to the documentation of that package and find the correct naming. I do this every single time. And for instance, is it an npm install auth0-bar-js or an npm install at auth0/auth0-bar-js? Well, in this instance, it's actually the bottom one. But there might be something like auth0-js-bar, and this is the one I always get mixed up on, or auth0-bar-js. There's absolutely no room for human error when it comes to installing packages. So be aware of this. And like I mentioned before, well, the baddies, they try to misuse even characters that can be mistaken for one another. For example, we get asked a lot, is it auth0 or auth0? Just for the record, it's auth0, but it's hard to distinguish an O and a 0, especially with certain fonts. Now, with this font, it does highlight the 0 with a dot in the middle, but if I hadn't put those together, then I wouldn't have noticed that the top one is actually an O and not a 0. So just be aware that there are people trying to misuse the names of packages and trying to create packages with a typo in the name deliberately, just so that they can inject some code through those malicious packages. Now, let's look at an example that my colleague Sam created, who did not, this is not published, don't worry, but it's used an npm link to demo. And in this example, we can see a malicious npm package which just imports the auth0 package and does something extra as well. It also steals everything in your local storage. So if we click on the login button, we do get redirected to login. It's not configured properly for this demo, but you can see the functionality of the original auth0 package still works. So it's still using the original auth0 SPA JavaScript SDK under the hood, but it does the extra thing of taking everything that is stored in local storage and sends this to a malicious server, which in this case is actually Sam. So be careful of Sam, I'm joking. So be careful when installing packages. Right. We've just seen a huge problem, and I think someone in the chat said, so what should we do? What's the solution? So one of them is to use reproducible builds with a log file. If your package manager supports log files, try to make use of those, because I know NPM does and Yarn does. I'm pretty sure others do, but I think that other language package managers also support log files. So what you're doing is you're locking down the version of your packages you want to use. So you can be sure that if in the future somebody tries to publish a malicious version of a library you use, you won't install that by default, but you still have the chance to manually upgrade if you want to. Also, use long-time support if you don't care about bleeding edge features, if you don't need the latest and greatest. Use this because it means less updates, means less change for malicious code to be pulled in. And I know, we have to test everything, okay? We really need to test more, but test all the things. You can run tests that assert only expected requests are sent out and no surprises. So if you have an application that sends certain API requests, you can test the application to send those requests. But if any other request goes out, the test will fail. So you might see that certain malicious requests may be stealing your tokens or your credentials and going to a malicious server. So if you write tests that assert only expected requests, make sure that you check that no other requests are going out. And you can also make use of the integrity attributes to a script tag if you're using a CDM, for example. And that's so that the browser will verify the integrity of a package. And how does that work? Well, here we have the regular HTML script tag where we're passing a source, maybe a cross origin, and you can also pass along an integrity attribute which will start with the hashing algorithm. In this case, it's SHA-384, and then the hash of the JavaScript file we expect. So we first need to create a hash of the JavaScript file. Once we have that, we can pass it along to the integrity attribute, and the browser will check that hash for you. So if something has changed in this JavaScript file, either by a transfer or man-in-the-middle attack or something along those lines, what the browser is going to do is going to let you know that the hash you expect it to be, well, it doesn't really match the contents of this JavaScript file, so it's not going to load it for you. Now, the last thing you can do is support bug bounty programs, and especially for important open source projects, because the more resources they have, the more time and effort they can put into making sure that open source libraries and projects are secure and up to date. And well, that's it from me today. I just want to say thank you all for listening. I'll check the chat now for any questions, but feel free to reach out to me on Twitter as well.
We have a question from Alice. So she says, if we accidentally click on these malicious links but didn't enter any information, does our computer get hacked? What should we do in this case?
Well, that depends on the type of attack. If it's one that's disguising as, for example, a banking app, if it's a CSRF attack, then you might be in trouble if you have your credentials saved. But like I said, modern browsers are already doing a lot. So for this to work, it's normally more than just clicking on the link.
Okay. For the next minutes, we'll be having a Q&A session. So everyone feel free to leave your questions in the chat box, and Anna will be here to answer them. A lot of people are asking if you will be sharing the slides. So before that, the recording will be available on the Women Who Code YouTube channel. So the recordings will be available there, and I'll link it again over here. Yeah, so the slides.
Yeah, I can share those right now. If you need to. And I can make that happen. Renaming it. Sorry. Okay. Thank you all for coming. I am clicking the share button right now, and I will get up to you. My kids are at home. I hope they don't make too much noise in the background. Here are the slides. I think I put the showing settings correct, but please let me know if I didn't do that. And if you go through them and see, yeah, I'm on power. If you see any mistakes, or not mistakes, any questions or anything, if you see mistakes, let me know too. But yeah.
We have another question. Do you have a favorite framework that builds in a lot of C by default? For example, do you like Django?
So I'm a front-end developer. I guess I need to ask Jessica more about that. She's in the chat, but she's just getting into identity and security, so I'm not going to put that pressure on her either. Front-end wise, Angular, as far as I know, is probably the best out there when it comes to security.
Okay.
But I can definitely look into it, and if you want to DM me on Twitter, I'll get back to you as soon as I speak to my colleagues.
Okay, and you guys can find Anna's Twitter link in the chat. It was shared. by Jessica. So there's another question. Are there any learning resources that we could check out to learn more about security for apps?
Yes. So I'm going to drop a link here in the chat. It's the OWASP Foundation. They don't have any. I just saw someone was wanting a hands-on way. I do know a friend of mine who is very well known in the security scene does give out free courses. I am going to drop his Twitter in there too, just so that you can follow him and check out his courses and stuff. And there's, I think those two are the best places to start. I always learn so much from Philippe.
Awesome. So Jenna says, thank you, Anna. This was very informative. I would love to know how you got into security.
I joined a company called Auth0, and we're very focused on identity and security. So Auth0 has an out-of-the-box solution to authenticate your applications. But of course, if we're doing that, we have to be really, really big on security and really hard. So that's why I got more into security, just to understand basically what we do better. And also, as soon as I started digging deeper into it, I was like, oh, it's actually really interesting. So
Awesome. So we have another 10 minutes. So if anyone else has any questions, feel free to leave them in the chat and Anna will be answering them. So there were a couple of questions about any resources with a systematic and hands-on way of teaching. And as you said, you did share a couple of resources in the chat. A Twitter link to one of your friends who hosts a lot of free courses. So you guys can check that out.
Yeah, and I just saw one about
What
security.
certifications or courses should be okay?
It really depends how far into security you want to get. So if you're just building an application and want to make it more secure, then you don't need a certificate. If you want to become a security expert, then maybe you should be looking more into the infosec scene and taking security certifications that are like official ones, like certificate. I can't speak anymore. It's too late. Certified ethical hacker ones, and there are lots out there. So it depends how deep into security you want to get. But if it's for the sake of making your applications more secure, you don't need a certification. Courses, good starting point. The OWASP documentation, also what I shared about Philippe. But if you want me to dig deeper into more courses, I can ask our security team in Auth0, and I'm sure I will get some really good answers.
Awesome. So if you guys would like to know more about that, feel free to connect with Anna on Twitter. So Alice also asks, if I want to learn self-taught courses, how can we? Okay, I guess how if I want to give self-taught courses, how can we? Okay, I'm sorry. How can we demonstrate our skills if we've been following self-taught courses?
Yeah. So the best way to demonstrate your is to actually implement them into an application. It might be just a test demo or something, and then try to hack yourself, right? Like, be both parts of the story. And if you don't feel confident enough to, well, hack yourself, I know there's a lot of security groups out there. I know there's a lot of people in the infosec world that would be willing to like give you feedback and test it out for you and so forth. But always, for me, practice is so important. Hands-on approach, like building a demo, implementing security measures, and then trying to like break them is always a good way to go.
That's amazing. I totally agree with that. It's nothing better than trying to test yourself to see how far you can go.
Yeah, definitely. And it's such a great experience because you get to test out being both sides of the story, right? The ethical hacker and the baddie. But
So
yeah,
it
only be
looks
the baddie on your own applications, please. I'm not encouraging doing anything else.
so it looks like we don't have any questions anymore, I'll just reshare the presentation link and um, the link to the YouTube channel as well as Anna's Twitter. So you guys can feel free to connect with her there. If you guys have any audio issues or missed out on any part of the session, you can feel free to check out the YouTube channel. It'll be uploaded there. And if you still have any questions, I'm sure Anna will be um, willing to answer any of them if you connect with her on Twitter. So if you guys have any other questions, feel free to leave them here, or else we can close the session.
Awesome. Well, thank you all. And yeah, my DMs are open, so you don't even have to follow me if you don't want to. You can just reach out, and I'll be more than happy to help. Thank you all for coming. And
Thank you so much, Anna. It was a wonderful session, very informative.
thank you. Have a great evening, morning, wherever you are in the world.
Thank you everyone for joining. Feel free to check out the other sessions in the session board. We have a couple of sessions coming up soon. So meanwhile, you could also connect with companies in the expo within their booths. So, thank you everyone.